Welcome to this explainer. Okay, if you're learning SQL, you already know the drill. Writing queries starts off feeling pretty simple, right? But man, very quickly, your screen just turns into this incredibly intimidating wall of text. Well, today I am so excited to help you transform that messy SQL into beautifully organized, readable code using Common Table Expressions, or CTEs for short. By the end of this step-by-step tutorial, you're going to have a brand new tool in your coding tool belt that's literally going to make your life so much easier. Let's just quickly look at our roadmap for today. We're going to cover 6 key sections. First, we'll meet our employee data. Then we'll look at the old way of doing things in the subquery tangled web, followed by enter the CTE magic. After that, we'll go through a step-by-step CTE guide, look at combining multiple CTEs, and finally, wrap up with a CTEs versus subquery showdown.
All right, let's kick things off with section 1, meet your employee data. But first, I have a quick question for you. Have you ever been completely lost in your very own code? I mean, we've all been there, right? Staring at a massive wall of SQL text and just feeling that absolute dread. You write it on a Friday, come back on Monday, and have no earthly idea what you were even trying to do. Well, understanding our data ingredients first, before we even type a single line, is absolutely crucial for clarity. So to make this super concrete, let's look at some standard HR data. And here is our starting point. Imagine we've got 2 pretty simple tables. One is for employee demographics, so that's got your employee ID, gender, and birth date. The other is the employee salary table, which just has the employee ID and their salary. Now, as a data analyst, you're naturally going to need to join these 2 tables on that employee ID to figure out some key metrics, things like the average, maximum, and minimum salaries, all grouped by gender.
Which brings us to section 2, the subquery tangled web.
So in traditional SQL, when you need to perform calculations on top of other calculations, you'd usually reach for subqueries. And a subquery is essentially exactly what it sounds like. It's a query nested inside another query. Literally a select statement trapped inside another select statement. Imagine you write a query joining our 2 employee tables to find the average salaries by gender. Okay, simple enough. But what if your boss then asks for the overall average of those averages? Suddenly, you have to wrap your first query inside a whole new query. You end up with brackets inside of brackets inside of brackets, and it becomes a real nightmare for beginners to read. Think about our ultimate end goal here, getting clean, aggregated metrics that let us compare things, like male versus female average salary. Now here is the kicker. The final data output is exactly the same whether you use a messy, deeply nested subquery or our new, elegant CTE method. The end user, they won't know the difference. But you, and frankly, whoever has to read your code next, absolutely will. Okay, let's move on to section 3, enter the CTE magic. So how do we get that exact same delicious data without the massive headache? Well, the crucial point to understand here is that a CTE, which stands for Common Table Expression, basically acts like a temporary sticky note or a blueprint for your data right before you execute your main query. It lets us define a subquery block that we can fetch immediately. Now, this is really vital to remember. This is not a permanent file. It doesn't write some whole new table into your company's database. It's just a temporary workspace that exists literally only for the duration of your current query. Just think about the massive difference in nesting levels. A subquery setup creates these deep, confusing layers of nesting where you're forced to read your code backwards, from the inside out. But a CTE, it keeps your code wonderfully flat and readable, laying all your logic out sequentially, step by step. All right, grab your keyboards because here is section 4, step-by-step CTE guide. Okay, let's actually build one together. First, you kick off the block using the keyword with. So you type something like with CTE_example as. Next, step 2, you open up your parentheses and just drop your complex salary joining query right inside them. That's where you're grabbing gender, average salary, max salary, grouping it all up by gender. And finally, step 3, you close those parentheses and immediately run your select statement right against it. So you just say select the average of your average salary from CTE_example. Do you see how it reads so logically from top to bottom? Just remember, you have to use the CTE immediately after creating it. You can't reuse it later in the session because, again, it's not a permanent table. And hey, here is an absolutely brilliant pro tip to make your code even cleaner. Instead of creating aliases, those temporary nicknames for your columns deep inside the guts of your code, you can actually declare them neatly right at the very top, right next to the CTE name. You can literally write with CTE_example and then immediately in brackets write out your columns: gender, AVG_sal, max_sal, min_sal, count_sal. It clearly tells anyone reading it exactly what columns this temporary workspace is going to output before they even get into the heavy logic. Now, what if our HR request gets a little more demanding? Let's check out Section 5, Combining Multiple CTEs. The absolute beauty of CTEs is that you're not limited to just one. You can actually stack them within a single query. You just define your first workspace with CTE example as, put your logic in brackets, and then, instead of writing a brand new with statement, you just pop in a comma. That single comma is the magic separator. Then you write CTE example 2 as, drop in some more logic inside brackets, and finally, you just easily join them all together at the very end with a simple select statement. Let's look at a concrete, real-world use case for stacking them. Imagine your boss comes to you and wants a list of employees born after 1985 who also make over $50,000. With CTEs, it's a breeze. You create one CTE pulling from the demographics table where the birth date is greater than January 1st, 1985. Then you create a second CTE pulling from the salary table where the salary is strictly greater than $50,000. Finally, in your super clean select statement at the end, you just join CTE 1 and CTE 2 on the employee ID. It completely isolates your logic and makes it so easy to follow. All right, let's put these two contenders head to head. Section 6, CTEs versus subqueries showdown. Comparing these two approaches side by side really drives the point home. A nested subquery completely forces your brain to hunt for the innermost select statement, figure out what it's even doing, and then painstakingly work your way backwards to the outer query. Honestly, it's mentally exhausting. But a clean CTE block, it's an absolute joy. It reads just like a book, right from top to bottom. First, gather this data. Okay, next, calculate this. And finally, give me the end result.
So as a beginner stepping up into intermediate SQL, when exactly should you reach for a CTE? Well, always choose a CTE when you want to maximize readability and avoid those nested spaghetti code nightmares. They're absolutely the perfect tool when you need to manipulate data step by step for immediate use, but you don't have the database permissions or even the need to actually create a permanent table in your company's system.
So here is my final thought for you to ponder today. How much time could you save, and honestly, how much future frustration could you completely avoid by rewriting your messiest nested logic into these super readable CTE blueprints? I highly encourage you to open up your SQL editor right now, find a deeply nested subquery you've written in the past, and just try refactoring it with the with clause. You're going to love the results. Thank you so much for joining me in this explainer. Now go write some clean code.